So in 7.3, we did systems of linear equations, the triangle ones, 3 variable 3 equations, and then we started partial fractions. So with number 1, you're just going to take this z and plug it in to the one with 2. 2y minus 3 equals 7. 2y equals 10, and y equals 5. That's the second variable. Then you're going to take the z, plug it in with the y, plug it in, and you get 3x plus 5 plus 2 times 3 equals 8. 3x plus 5 plus 6 equals 8. 3x plus 11 equals 8. 3x equals negative 3. And x equals negative 1. And then again, make sure you're writing your answers in coordinate point form. Negative 1, 5, 3. Easy stuff, right? Okay, then comes your 3 variable 3 equations. So I'm going to number these so that we can be descriptive. And I want you to do the same on your quiz. And I want you to make sure you're showing your steps. If you skip steps, I cannot give you credit should you make a mistake. So you want to make sure that you're doing it. So if I pick 2, give me an example of which ones you picked.
1 and 2.
1 and 2 and canceled out? The z's? Okay. So I could take that first one and I would have had to multiply by negative 5, right?
Mm-hmm.
And then take 2. And I get negative 2x minus 3y cancels equals negative 1. And this we're going to call new 1. Then I have to use 3 because I didn't use it the first time. And I have to cancel the same variable, which let's say we're going to cancel z. Okay? Easier to do is take number 2 and multiply it times a negative 3. And I get negative 5x minus 7y. These cancel equals negative 1. And that is new 2. Now I need to take new 1 and new 2. And this time they're not going to cancel outright. So I have to change them. And this time I actually have to change both. So if I did this by negative 5 and this by positive 2, I'd get 10x plus 15y equals 5. And then negative 10x minus 14y equals negative 2. These cancel, and I get y equals 3. There's my first variable, and then I follow the same process as the back substitution. I'm going to pick, bless you, one of the new ones to plug it into. So let's say I take this one. Negative 2x minus 3 times 3 equals negative 1. Negative 2 minus 9 equals negative 1. Negative 2x equals 8. X equals negative 4. There's my second variable. And then I need to take and plug them back into one of the originals. So I'm going to grab the first one because that's the least amount of coefficients. X, which is negative 4, plus 2 times y, which is 3, minus z equals 3. And I get 2 minus z equals 3, negative z equals 1, and z would equal negative 1. And then my coordinate points would be negative 4, 3, negative 1. So your process might have been different if you canceled out different variables, right? Your new 1s and new 2s are going to be different, but your end result should always be the same. Questions? It's so easy to make a mistake, right? That's why you're going to make sure you show your work, because that question's 20 points out of your quiz. Okay, so pick these two. You multiplied the first one by negative 3?
Yeah.
Okay. So negative 3 times row 1 would be negative 3x minus 6y plus 3z equals negative 9. And then 3x plus 7y plus 5z equals 14. X's cancel and I get y plus 8z equals 5. That's new 1. So remember, you're not going to skip steps, because if you make one little mistake and you get it wrong, you don't want to lose all that credit on the quiz. This question is technically 2 questions, so it's like 20 points. You want to make sure you're careful with it. Okay, so then you had to use 3, right? Did you use 1 again? Minus, oh, thank you. I rewrote it wrong. This is minus 5z? That one?
The second term,
Yeah, so then this would be minus, so this is 2. Okay, thank you. negative 2z. Okay. All right, sorry, then what was your next step?
I used
2 and 3 to cancel again the x, right?
yeah.
Okay, so 2, would you multiply by 3? And 2 multiplied by 2 and 3 multiplied by 3. Yeah, okay. So you get 6x plus 14y minus 10z equals 28. And negative 6x minus 3y minus 9z equals 24. All right, and then that's new 2. Then you got to use new 1 and new 2. So y minus 2z equals 5. 11y minus 19z equals 52. Did you multiply the top one by 11? Or negative 11?
Yeah.
Yeah. And z's negative 1. Take that, plug it back into one of the new ones so it can go in here or here. I would have picked the first one just because it's smaller numbers. There's the second one, and then those have to get plugged back into the original one of the original ones. Again, I'll grab the first one just because it has less coefficients, but you could grab any of them. And then x plus 2 times 3 minus a negative 1 plus 1 equals 3. Plus 6 plus 1 equals 3. And x is negative 4. And then you'll write it, negative 4, 3, negative 1. Questions on that one? Okay, then came your partial fraction decomposition. So yesterday we started ones that didn't have a repeated factor. So the first thing we're going to do is factor the denominator here. And I would get x minus 4 and x plus 2. And then I'm going to say a over x minus 4 plus b over x plus 2. Did anybody switch that order and do a over x plus 2 and b over x minus 4? Okay, so you can. It's totally fine. Just pay attention when you get to the end. The right one should match the x minus 4, like you'll be switched. So now we say what's missing from our denominator to the one that the one on the left that we originally were given. This is missing the x plus 2. This is missing the x minus 4. And then I'm going to ignore the denominator and set all the numerators equal to each other. 3x minus 1 equals a times x plus 2 plus b times x minus 4. And then we need to, one at a time, cancel out the a and the b. So you can either say, what's it going to take to cancel this out, which is x equals negative 2. What's it going to take to cancel this out, which is x equals 4. Or I can go back up to my original denominators and set them all equal to 0 to figure out what those points would be. Then we're going to take and plug them in. So I'm going to take and plug in negative 3 everywhere there's an x. So negative 2. Negative 2 minus 1 equals a. Negative 2 plus b. Negative 2 minus 4. I get negative 6 minus 1 or negative 7 equals. Here's my 0, so that's gone. B times negative 6. And I get b equals negative 7 over negative 6 or positive 7/6. Then I'm going to work out the next one. So x is 4 now. Again, I'm going to plug it in everywhere there's an x. So 3 times 4 minus 1 equals a times 4 plus 2 plus b 4 minus 4. Here's my 0 again, so that's gone. 12 minus 1 equals a times 6. 11 equals a times 6. And a would equal 11/6. Everybody with me so far? Okay, so now I'm going to take those and plug them back in. So the a, which is 11 over 6, is going to go over x minus 4. And the b, which is 7 over 6, is going to go over x plus 2. So like Megan, your order switched, but the right, like 7 over 6 is still with your x plus 2, and 11 over 6 should still be with your x minus 4. So it's fine. You cannot leave a fraction within a fraction. These are complex fractions. So the easiest thing to do here, so if you're not focused, I would probably pay attention, is take this and bring it down to the bottom. So it becomes 11 over 6 times x minus 4 plus 7 over 6 times x plus 2. Leave it like this, you're losing points, so don't do that, okay? You can even go one step further and factor out a 1/6. So I will take this answer is totally fine, But on standardized tests or ones that are like multiple choice, they will take out the 1/6 and leave it as 1/6 times 11 over x plus 4, minus 4, sorry, over 7, plus 7 over x plus 2. So standardized test, again, would write it like the second method. I will take either method. Okay, the other thing is also remember that if there's a negative in this location, we bring it down to the middle to make it minus. You cannot leave a negative in a numerator. Questions? Okay, so the good news is, I text Miss Boyd last night and I said, do I have to teach repeated factors? Do they need it next year? And she said, no, you don't need it next year. So we're going to skip the repeated factor part, okay?
Yes.
If you go to Calc BC, which some of you might eventually get there in college, you will see it, but you'll have forgotten it by then anyways. So we're not going to stress out about it, okay? Because you have to do it a completely different way. You have to set up systems of equations, all right? So in your free time, if you want to learn, there's videos on YouTube. Yeah? 9. No. Yeah, 9. Because the 1 counts for 2. Yeah. Yep.
Are there any word problems?
Yep. Hey, good segue. We're going to talk about your quiz. So your quiz, which is tomorrow, remember you can have a scientific calculator only. Trust me, you're going to want it. Okay? If you don't bring it, that's fine too. I'll enjoy the looks on your faces as you're multiplying large numbers together or dividing decimals, which you do so well without a calculator. All right, but again, scientific only, and you'll have it the whole time. So remember in 7-1, we did systems of equations with substitution and graphing. We did these linear and nonlinear. So remember you had things like lines with parabolas. You have a line with square roots, that kind of stuff, where you want to graph your line, graph your parabola, and then figure out the exact points where they overlap. You had all of these different kinds of word problems. Break even, where you have to round that number up. Interest, geometric, which is like your perimeter. You can do perimeter, you can do area, that kind of stuff. And then sales, where like you're selling the tickets or you're selling items, that kind of stuff, where you're going to set up a system and solve it. So you will see multiple of all that stuff. Remember your special cases for your substitution and your graphing. If your variables cancel out, and what's left is true, then it's all real numbers. If what's left is false, it's no solution. And then if it's a graph, if they never intersect, it's no solution. So parallel lines or parabola that points up and a line that runs down, right, would never intersect. Those would be no solution. And if they are lines, the same line, if they end up graphing the same line, then it's all real numbers. Those are your special cases with graphing and substitution, and also elimination they carried over. So there are practice on all of these on your quiz review, except the break even, which we did in the notes and on the warm-up, and the graphing nonlinear, which again we did in the notes on the warm-up. So if you want to go back to those things, that is not on your quiz review, okay, but you could see it on the quiz. Everything else, there's an example. Oh, and the geometric. I don't think there's a geometric, but the perimeter one. 7-2 was elimination, and we added in the equilibrium point. So remember, for equilibrium point, we set our revenue equal to our cost, and we have to, actually no, they're both p-value. They both say p equals and p equals. You set them equal to each other. But for these, you need an x and a p. You need a number of units and a price per unit. So when it says equilibrium point, it is more than just the x values. You got to plug them back in and figure out what price to make it. And then 7-3 was your 3 variables, 3 equations, and the partial fraction decomposition that we just did on the warm-up. The review is on Canvas. Again, it's on the quiz assignment itself. You've got at the top your systems of equations where it lets you choose how you solve it, okay? And then you've got your graphing because you are going to have to graph. And then you've got your word problems. There's your interest. Okay, so it says an investor has $10,000 invested in 2 stocks. One stock pays 15, the other 16. The total income is 1,520. How much is invested in each? So here's my x. My x would be 0.15. How much money is invested at 0.15? And my y, how much is invested at 1.6? Total invested is 10,000. 0.15 times x plus 0.16 times y is the amount, God bless you, that was the income on it. So then I would multiply this whole thing by 100. And then you can either do substitution or you can do elimination. What would you have chosen? Elimination?
I would have chosen
Substitution. Okay, so then let's say that x equals 10,000. Oops. Minus y. I'm going to take that and plug it back in there. So distribute that. So y is 2,000, which means you're going to invest 2,000 at 16%. And then subtract that from the 10,000. And that's how much you're going to invest at the 15%. And my advice would be to take a second to like multiply that out in the calculator. So if you do 2,000 times 0.16 and 8,000 times 0.15 and add them together, you should get that 1,520. Hannah. 100. Am I missing a 0? Yep. Right. One more 0. It still lines up the same, right? I just did it wrong. Yeah, everything else is still the same. I just did that. Left a 0 off. Yeah.
how many were
One or stock one. There's the sales one. There's your equilibrium. Back substitution. Systems of equations 3 variables review. And the partial fraction decomposition. In the instructions I wrote, you can stop at 16, go through 16, because 17, 18, 19 are your repeated factors that we're not going to do.
All of them, are we gonna have like, the plain one on the homework?
The plain one is not on your quiz. I'm not making any promises test-wise, but it's not on the quiz. Yeah. Yep. No. First of all, the class isn't 60 minutes. You can come in and ask a couple questions, but you're not going to get a full 30 minutes. You might get like 15 minutes.
Oh.
Yeah. Any other questions for quiz prep? Any questions from last night's homework? Well, that's a good sign.
Last night's homework was like the first time I got 100.
Good.
On a homework in like forever.
Good.
Which was
The
really
first time in
It felt
forever.
really good.
Yeah. Yeah.